This is the last lesson in our unit. It is lesson 16, Spontaneity. So how can we predict if a reaction is going to be spontaneous or not? We must use something called Gibbs free energy, because we said exothermic reactions are more favorable than endo, and spontaneous reactions are usually those that increase the randomness of the universe as opposed to decreasing the randomness, but somehow we need to combine enthalpy and entropy together to be able to predict whether a reaction will be spontaneous. So Gibbs free energy, delta G, is going to be equal to the change in enthalpy minus the temperature times the change in entropy. So if delta G is less than 0, the reaction will be spontaneous, meaning it will just occur. If delta G is equal to 0, it means the reaction is at equilibrium, meaning that it goes back and forth. And if delta G is greater than 0, that means the reaction will not be spontaneous. So in the forward direction, the reaction is non-spontaneous. However, if you go backwards, like if you have products and they are combining to give reactants, that reaction is actually spontaneous. So the standard free energy of formation, delta GF, is the free energy at 1 atmosphere, and this formula again should look familiar, just like Hess's law. So we have a table full of standard free energies of formation for compounds, and we can find the delta G by using the equation the sum of the moles times the delta G formation of products minus the sum of the moles times the delta G of formation of reactants. So that's one way you can find delta G for a reaction. Now, delta G depends a lot on temperature. If we want to find delta G at other temperatures, so using this equation we can only find the delta G at 25 degrees Celsius. But if we want to find delta G at other temperatures, that's when we need to use our delta G equals delta H minus T delta S formula. So this takes into account both the enthalpy and the entropy. Now, if we have a exothermic reaction, negative delta H, and we're increasing the entropy of the universe, we're making it more random. Both of those things are really good. And so if delta H is negative and delta S is positive, that reaction will always be spontaneous because we want that to happen. So it's spontaneous at all temperatures. However, if we have an endothermic reaction, positive delta H, remember you have to put energy into it, and our universe is becoming more ordered or less random, so we have a negative delta S, those are both unfavorable conditions, so our delta G will always be positive, meaning non-spontaneous. That does not want to happen. But here's where it gets tricky. So what if we have an exothermic reaction, which is good, but our entropy is decreasing, which is bad? If this occurs, you have to consider this T. Okay? At low T, the reaction will be spontaneous. So if they're both negative, it will be spontaneous at low T. Remember, negative is low. If they're both negative, it will be non-spontaneous at high temperatures. So it's spontaneous at low temperatures, not going to happen at high temperatures. If we have an endothermic reaction, so you have to put energy in, but our universe is becoming more random, that's a good thing. If they're both positive, it will be spontaneous at high temperatures. So if you plug in a high number for T, your delta G will be negative. But it will be non-spontaneous at low temperatures, and we'll do some practice problems with this in class.